Yeah, my name is Fabian Fulholm, and this section I will try to explain the concept of my project and architecture and some sub-project and the future and the development that we are going. First of all, it was quite clear that in the 2020 we will have a lot of data to handle. Because today we have 150 gigabytes per person, but the data that we have today is only 2% that expected in 2020. The big problem that we have is we try to use a common file system that is present in our computer or in our storage area network, but is some like to put the tape on the street to keep the street. No, that we need something new. For this reason, we started with RestFS, to rethinking completely the story. The main goal is to create high scalability, high availability network object store. We want to remove the idea of the file. You can handle as a file, but we want to work on the object. And for this reason, we call object storage. Another interesting thing, we start the project because we want to testing to find new technology, new paradigm that is making today a big framework to try the new technology. First starting point, this is quite famous. This is a Hadoop concept. Moving computation is cheaper than moving data. This is our first paradigm. The second, that comes from Amazon, there is always a feed waiting around the corner. And the last that comes from Ruby guy, we have to decouple as much as possible because we handle so many data, then we have to decouple, and the element that made your solution have to evolve in different life cycle style. Then you need to decouple everything. From these three paradigms, we create 5 pillars. Now we work on the object. That means we separate the data from the metadata. We try to mark each element with a revision or a hash to make a unique identification. This will be faster to look at. We want to introduce the cache, more intelligent cache, based on callback. You don't have to pull, you will be notified. This is one of the main concepts of our cache. We will notify if something changed. Also the transmission. Now we work in the network, the latency, the long distance is a big problem. We want to create a wide area network storage. We don't want to create a single storage for a single data center. Then we need a compression. We need to transfer the data only if you need and what is changed in a special way. We also, to simplify the communication, we have today many firewalls, many protections, then we have to work on HTTP as much as possible. Obviously, we have to be distributed, to decentralize. You remove any single point of failure. That means we need to make replication of the data. We need to spread around on multiple nodes. We have also to look up your data all the time or as much as possible. You don't have to fix configuration. You need to retrieve the configuration that is better for you in the time that you use the data. And also, obviously, today the security, in a special way, after the NSA, is quite an important thing. Well, our structure is very similar to Amazon. Then we have more or less the same concept. We have bucket and we have object. Objects are stored in bucket. What doesn't exist today in S3 is the cell concept. The bucket resides in a cell. I'll try to explain a little bit better. You have a client, the client made a lookup on DNS name, they receive back a list of IP of resource locator, a list of cells that contain your data. Now you make the query to DNS, in this way you find where is your bucket, then you have a list of resource locator. That means you still don't know exactly where it is, you know only the cell. For each cell, you can retrieve the list of the server that handle your data. Then we have 3 levels. Now we have a first lookup, more global, that is more handled by DNS. We have a cell 1 that give you, okay, my cell has this dimension, I have this list of the server, please use this one. Or I have a couple of servers that is full, please move on another region, and so on. That is only for discovery, and obviously from all this information, the lookup server return you also the type and priority. No, I'm a bigger than I can handle 400,000 connection, or a small and I'm full for 90% and so on. To retrieve the data when you have the list of the server, that means metadata server and object, and data that you can start. You start, first of all, you need to retrieve the property of your object. Now you discover your bucket, then second step, you have to discover where is your object. And the property of the object mainly is to retrieve the signature of each element that you need. Then you have metadata. What does it mean, metadata? Mean who created the object, the size of the object, and many other attributes. The data reside in a different server set. That means also you can scale in a different way. Now, if you have many operations that read the metadata and less operation on write or read, you have different dimension of the cluster. Now, we are in a cell and we have different kind of cluster. One for metadata, one for object. All this information will be cached by the client. Now, you have a lookup. While we have federated authentication that you can use tokens, kind of similar idea behind of Kerberos. You have the famous subscription. No, I store some object in my local cache. Please notify server has to notify if something changed. And you have two cache, one for metadata and one for the block. This is a permanent cache. That means it's stored on the disk of the VM. That means also when you restart your VM, the data is there, and then you can only revalidate with the hash or with the ID your cache, that you don't need to transfer. When you have to make some operation, you need only to transfer the different, because you have all the hash, and you have to send the hash. If you have to read, you have to check what is changed and retrieve only the block that you need, because the other block is in your cache. We have the caches divided in disk and also memory to speed up, but mainly is a persistent cache. That is difficult to find another file system today. At the moment we don't have, but you can imagine immediately that you can handle a disconnected operation. You can sync your file system and resync when you will have connection. The infrastructure of the server. The architecture is divided in three main levels. We have a front-end level that is both with the client. We have a manager level that where we have the business logic, and we have a driver. You can understand that we have many pieces. No, we try to divide each operation in a separate, indecoupled piece of software. That means, we'll see in the next slide, that each element has a dedicated backend, dedicated database. That means you can scale up a specific function if you have a problem on a specific function. And also you can parallelize all the operations. Well, we can identify now the main service that is metadata, as I said. You can token for authentication. Well, we have authentication token. This is kind of section, end of the section. We have the resource locator in the cell. We have the callback service. We have the block device that you talk with the server between blocks. And we have also a log server to keep, if you need, the consistency between different plans. As I said, why we have a huge scalability? Because each element has a dedicated storage. And that means you can scale out from horizontal or vertical. That means also it's completely decentralized, because you don't have a single point that contains all the information. You can use all for each backend a separate database. We try to use as much as possible K-value to use NoSQL because it's quite fast, works very well for hash, or better, it's designed to work with hash. Then we can scale, also in this case, we can be very fast. We try to keep simple operation. No, we have a lot of database. We try to keep a single operation, atomic operation. In this way, we can conduct parallel operation. No, you don't have to wait. You can fire all what you need because you have different DB that you can fire. NoSQL is very fast. That everything is very fast. We also use on the backend on the server distributed memory cache based mainly in language HD to reduce the number of variations on the backend. But this is not really needed. Well, I want to give you a small example on internal that is probably you don't need to know what it's like. No, how is appear a bucket? Okay, a bucket has a name like a DNS. This is a DNS name. You will find through a DNS. And you have a set of properties that is famous metadata. Segment size, block size, max read, standard of the class, and so on. Why do we have block size, max size? Because your object is divided in metadata and data. The data has a block, then you can specify, like today you have the block on the file system, but we are dynamic. You can change your block depending on your file. If you know the type of your file, you can decide to use large block, small block, and also the blocks are collected in segments to reduce the time of the transfer. That sometimes you need to 500 blocks, then you can ask the segment. Then you don't have to ask 500 ID to the backend. You can say, okay, please send me the segment Y or Z or and so on. But also the size of the segment you can decide when you store your object, and you can change the size. Then you have metadata where you have all the properties, and you can figure out how many blocks, how many requests you can do, and the hash for each block. And this is handled by this side. On the other side, you have the block, and it's collected by segment, and you store it in a completely separate structure. A small difference, on the block side, we use a hash to track, for understanding if we handle the same block. On the property, we use a serial because we are able to handle versioning. You can enable versioning. And with serial, we also, through the serial, we implement a clock vector to resolve problem of a contemporary commit or disconnected operation. Couple of other, the ID, as I said, is a name. ID object is a URID, and in this segment is a combination between the position in the segment and the ID itself, and the chunk data is mainly a hash. That's this. You can read the ID of the single block. We build with the composition of each element. Bucket name, segment position, segment ID, position, and so on. In this way, we have a unique ID for all the environment. What you can do, let's say, is this is something that you can do in S3. You can create fake object that is kind of one point of the file system. Then you can connect one cell or one bucket to another bucket. Then in this way you can create an infinite file system. And also in this case, you have a unique path. That will be, the path will be the same on all the file system because it's based on DNS plus URL, like S3. But the nice thing is that you can mount bucket in bucket, like today in the file system. As I said, we have revision. We try to keep revision and versioning light as much as possible. Then we keep always the last version, and we keep the difference of the previous one to help a little bit the virtualization. This is very useful in virtualization. If you have to start a new VM, you can start from a code image. That means the time of replication of the code image is 0, because you don't have to replicate any data. On the block storage, this is today is a sub project. It's a little bit more complicated because it's based on a distributed block replication, mainly based on consistent caching. Then we try to keep as much as possible to handle the failure, not to re-replicate or rebalance the head. And unfortunately, from the previous one, well, we use the 3 copies, or rather, the user can decide which algorithm to write, 1 read, 2 write, 2 read, and so on. The security of your data, you can decide. That is quite famous. And on the back end, the failure is detected by gossip server, gossip protocol, and each node has to handle other 2 nodes that for the replication. It is a small cluster in the cluster. And in case of failure, we have an election to identify who is the master, who has to receive the data and replicate to other nodes. Then the infrastructure is we have a front end, and the front end is kind of proxy to the back end in case of the data. As I said, on the cache side, we have a distributed cache. We have a publish subscribe that you publish, please notify if this block or this data is changed. And we have a persistent cache on the client that is on the file. Well, as I said, security is important, but we use SSL protocol. You can decide if you want to encrypt on the block level, that each block can be encrypted on the server, on the client. Obviously, much better on the client. And we have an ACL and RestFS for schema of ACL. A small, why we use NoSQL, and why we try to keep everything in SQL with hash and value pair. You can see with Redis you are able to handle 550,000 requests per second with a single DB. That means you can install all the builder that you want. That from the concept of the SAD, inside of the SAD, the scalability, we don't have any limit in the scalability. That you can see also get and get is much faster. It's like 700,000 requests per second. With I think we try with over 10,000 clients. But this is a back-end performance. That the code the code is organized in 4 levels, but I already mentioned. We have a protocol interface, we have a service, we have a manager, and we have a driver. What I want to say, we follow a little bit, if you know the cluster FS, that each element can be replaced. Each element is decoupled. As a standard interface, if you want to do something better, if you want to, for example, on the storage, you can use our storage, the name is Pisa, or if you want to use the local disk, you can replace the driver and write the block on the local disk. And then you don't have to care replication and so on. In the management, if you want to do something specific in the versioning, you can override the versioning class and so on. Or if you want to another interface, now the interface on the protocol, on the TCP, we have 2 interfaces. One is S3. We have all the S3 command that we are completely S3 replacement. And we have our RestFS interface. That's the big advantage that you have all the data and the subscription to the callback. What we use, mainly we use everything Python because we believe it's more simple to attract people for extend and for make experiments, much faster for prototyping. And on the solution in the backend we use 0MQ and well, a bunch of other technologies. No, we use OAuth for authentication. No, we don't believe to store our credential in our system. Probably it's make more sense to use an external one. And yeah, for now the DHT, the distributed, the replication of the data is based on DHT. Today we use Camellia. We want to move pass-free or multi-dimensional distributed hash. The point is, okay, I told you a lot, probably you don't understand very well, but why you have to use RestFS? Or what is the advantage? You can use as a home directory. You can have a home directory everywhere in your device, a center point like Dropbox. But on file system level, no, you can mount. We have a fuse mount that you can mount, and you don't care where you are. You can use as an object storage application. You can run an application that uses directly the interface that can have advantage. You can use also for CDN, because we have this replication adaptive. This is one of the things that we want to do, make adaptation on request and scale out the system. Disaster recovery. We don't have any problem to replicate across different data centers. Mainly, that's not going to do that. I think the time is over. Well, if we want, some of these topics will be handled in the conference 2014 in CERN. I think the more interesting part is you can visit the experiment, the Atlas test plan in Geneva. That means I don't know how many meters below the ground, and the famous ring of 30 kilometers. And yes, that doesn't mean I don't want money, but I need mainly people that is interested, share the idea, props code. No, as I said, we use Python mainly because we believe in the prototyping, make the experiment, try to go forward. Now the site is not updated. I hope to update soon, and we are rewriting a big part. Then I think we retire. That means we remove from the website the 0.1 version because we don't want to confuse the people. I believe in 1 month we'll be available 0.2 that has a different scheme of distribution of the block. Then, please keep in mind 1 month. Check the site. Try to download. The nice thing is that all these components, I talked about a lot of components, but you can install without problem in a single VM. Now use a single DB, single server, and yeah. Then you can try on your system. You don't need to handle on 10,000 nodes or something like that. Yeah, you can start to try, and with everything is included, is made in Python that you can understand it. You start and it's done. Any questions?
Yeah, I think we have time for one question.
How does it compare to Ceph?
Well, I know that you come from Ceph. No,
that's quite interesting.
Well, our inspiration on the file system come from Ceph, come from OpenFS, come from ExtremeFS, come from TauFS. No, we try to collect all the very good idea, and from Ceph we get OSD, and especially with the distribution of the metadata, the auto-scaling of the metadata. Well, I think we are more for wide area network because we are on HTTP and DNS based. That's for lookup. No, that Ceph is more for high performance computing, but more connected in the data center. In the same data center, low latency. Well, you have latency, but anyway. Well, I think we are more on the side of S3. We want to increase the performance, but I think it's not for single application that has a very high load I/O on the system, but it's more for many requests. No, I probably you understand. I believe no. I don't know what you want to do in the future because I'm seeing a lot of interesting stuff. But anyway.
All right, thank you.